You have tentatively been asked to name a compound here in chemistry, and I'm first going to capture this compound given here and be able to take you through how you're supposed to actually do the naming of this compound. And of course, you've just turned to a topic in chemistry called organic chemistry. So let me be able to first write down the compound as per the way it has been written in the question given. And this is Cambridge IGCSE. So the compound is written as CBr2, and we have H, and then we have CH3, of course the CH2, then we have CH, then we have CCl. Okay, then we have C, then this is H, then again another CH, yeah, another CH, and we have CH3. So it is a very long compound. As per what I have been given in the question, you'll bear with me because I had to first be able to write it down before we can look into what the question wants us to give us the answer. So the question says name the compound. So name the compound below. So this is a compound that can actually be able to get found in organic chemistry as a topic. And whenever someone asks you to name a compound in chemistry of such a type, you are supposed first to write what you call an open structural formula of that compound, so that you can be able to identify the position of the availability of any single, double, or triple bonds, and be able to check on whether you can actually be able to trace any branching molecule as far as what you have been given is concerned. So we shall first be able to capture this in terms of giving an open structural formula of the compound. So I'll begin with C, this carbon. Then I'll have a H. Is that H? Look at that. And I'll be able to actually capture the two bromine atoms attached on this first carbon. Look at this. And of course, it must have actually been told that organic chemistry can capture alkanes, alkenes, and alkynes. We were told that alkanes have a single bond between the carbon-carbon atoms. So between two carbon atoms, there must be a single bond. Then we were told that alkenes, so these are alkanes, just a representation of what an alkane can look like. And then we can have this. This is an alkene. In any alkene, there must be a double bond between two carbon atoms. And of course, the last one is an alkyne, where there exists a triple bond between two carbon atoms. So that is just a summary of what you can have in terms of the three main compounds or hydrocarbons. And of course, you're calling them hydrocarbons because they get to that point of only consisting of carbon and hydrogen atoms in the structures. And if you look at organic chemistry too, it then can be able to involve the discussion of what we call alkanols with a general formula R or H. Of course, R stands for the alkyl group, the hydrocarbon part, the longest carbon hydrogen part of that compound. And every alkanol must have this OH. as the functional group in as far as all alkanols or alcohols are concerned. Then this same organic chemistry 2 might also capture the discussion of alkanoic acids with the longest hydrocarbon part or the longest alkyl part and this functional carboxylate part. And it can also be able to capture the discussion of polymers, which can either be natural or artificial. We have perspex, we have nylon, we have polyester, we have polytetrafluoroethene, we have polychloroethene, we have polythene, you see, we have silk, rayon. You see, all of them are examples of both natural and artificial polymers. And you can talk about aldehydes, you see. So organic chemistry has quite a good number of compounds that can get discussed. And of course, the applications in the environment can also be able to get covered under the same topic. So for the naming of this compound to actually get given, then you're supposed first to break down that in terms of giving an open structural formula. So we've actually talked about having a C, a hydrogen atom, and two bromine atoms getting attached on this carbon. There's this covalent bond, then there's this carbon atom, okay? Then we have two hydrogen atoms, okay? Another covalent bond, so we've actually captured carbon and two hydrogen atoms here. So we have another carbon atom here, then there's this hydrogen atom, then we have another carbon atom here. So for us to actually make this carbon atom to be completely able to have well bonded, we are supposed to put a double bond here. Why? Because every carbon atom must be surrounded by 4 strong covalent bonds. Why? Because carbon is number 6 in the periodic table. Its electron configuration is 2 to 4. So it has 4 electrons in the outermost energy level. So it strongly does the sharing of these electrons in terms of forming very strong covalent bonds with other atoms in each process of reacting. So for carbon to completely become stable, it requires 4 electrons. For the purpose of completely having that octet state of 8 electrons in its outermost energy level, it ends up sharing its 4 electrons with other atoms in its bonding process. Okay, so carbon 1, 2, 3, 4. Carbon 1, 2, 3, 4. Then carbon 1, 2, 3, 4. So we are here. And this has 1 chlorine atom. Okay. So you can have this. So you can look at this carbon atom. So you have 1, 2, 3, then 4. Let's go to this. We have a C here. Then we have a hydrogen atom. So this and this are done. They're here. Okay. So and then we can have this. It is here and then this. Again, we have another C here. Then we have this H. So there must be another double bond here. So that we can be able to have, so we have this 1, 2, 3, then 4. Then this 1, 2, then 3, 4. Then we have this 1, 2, 3, then 4. Then we have the last C. Then we have 3 hydrogen atoms. Okay, this is here. Then 1 carbon atom, then 3 hydrogen atoms. So we have done actually the drawing of this open structural formula. Okay, and next is to look at the longest carbon chain. Let's look at this. So 1, 2, 3, 4, 5, 6, 7. So 7, that must be able to have a parent name which is hept. Hept. Okay. Then of course we have double bonds that must be in. So it must be something hept then in. Okay. We have 2 double bonds. So what do? Let's look at their position. So we have 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms. So we can derive its parent name as hept. Of course, hex means 6, pent means 5, but means what? 4, prop means 3, eth means 2, met means 1. Dec means what? That is the ken, the kin, the kind. It can be an alkane, alkene, or an alkyne. That means 10. Then nonen, nonin, nonine, that is 9. Then we have octene, octane, octine, that is 8. So hept, because of the 7 carbon atoms. In, why E-N-E? Because it is able to capture double bonds. And double bonds can actually get associated with alkenes, kin. So in. Then the first double bond is on the, we need to look at the double bond that's called the end of this structure. So this double bond is very near to this other end than this other part. So you see, 1, 2. You see, 2 carbon atoms reach this double bond. Then here we have 1, 2, 3 carbon atoms. So this double bond is near to this end. So you can be able to actually start numbering from this end. Before numbering can begin, look at where the double bond is. And you need to begin the numbering of those carbon atoms starting from that end where that double bond is very nearer to the end of that compound in terms of that open structural formula. So you have 1, 2. So we have 2. Okay. And because there's this other double bond, where is it found? So let's see. 1, 2, 3, 4. It's found on the 4th. Correct. So because they are 2 double bonds, you can say di. If it was 1, you could have actually said just H2 in. But because we have the first double bond on the 2nd carbon and the other double bond on the 4th carbon, so we have 2 double bonds. You can be able to say hept 2, 4 di in. Di means 2. So 2 double bonds between 2 carbon atoms at 2 different positions within the structure. Okay, let's look at any branching molecule that is not hydrogen. Because branching molecules must not be hydrogen atoms. Any other molecule. It can be an ethyl, a methyl, a chlorine atom, a bromine atom. So we have Br, Br, and Cl. So alphabetically, if you find more than one branching molecule, you need to actually consider looking at which one comes first in terms of the alphabetical arrangement. So B starts, then C can actually come later. Of course, letter B has to actually begin, then letter C comes later. A, B, C. I think you know that. So let's see. This Br is on which carbon? The 7th. So you can say 7 dash bromo, comma. And because they are dual, we can actually be able to say dibrom. So then that will be 7, 7. So the first bromine atom on the 7th carbon, so 7. Then comma. The other bromine atom on the same 7th carbon, so 7, 7. Then dibromo, okay, comma. And then there's this other chlorine atom, so you can say 4 dash chloro, okay, hept 2, 4 diene. Yeah, that's what you're supposed to have. Very good. So the naming becomes 7, 7. Why? The first bromine atom on the 7th carbon. The other bromine atom on the same 7th carbon atom. So 7, 7 dash, and because there are two, you can say dibromo. If it would have been one, would have actually just said bromo, then 7 bromo. But 7, 7 dibromo, comma. And where do you begin with bromo? Alphabetically, B comes first before C. Then 4 dash chloro, to mean the chlorine atom is attached on the 4th carbon. So 4 chloro. Then you can say hept dash 2, 4. The first double bond on the 2nd carbon atom, the other double bond on the 4th carbon atom. So 2, 4, and then because there are 2 double bonds, you can say diene. Very good. That becomes our answer.